All right, let's see what we can do with this one. This one, we're going to have to use that technique again of completing the square, just like we've learned how to do in ellipses. So let's go ahead and start to set that up in a way that helps us to figure out what this looks like. So that'd be a 4x minus a 4x squared minus a 24x. That's kind of one chunk. Plus, I'm going to put a negative 25y squared plus a 250y in the other chunk, and put the constant on the other side. All right. From there, let's go ahead and factor out so we get a leading coefficient that's positive. So it's going to be a 4. I'm left with an x squared minus a 4 from that is 6x plus something. Factor out a negative 25 here. So I have a positive first term. It's going to be a y squared, 25 out of that. Factoring out a negative 25 is a what? A negative 10. Equals 489 on one side. And all right, from here, we want to add a 9 to this one. And then add over here, half of that is a negative 5. Negative 5 squared is a 25. So that means then that to the right side, I need to add 36. And then whatever my black box says on the other one, I need to add a 36 or 25 times a 25, a negative 25 times a 25. $625. That's going to be a negative 625. All right, its equation's balanced. And in a situation, I can go ahead and start to complete the squares. So this becomes 4, and that's an x minus a 3 squared. Minus 25. What's left is a y minus a 5 squared. Equals what in the world is all of that stuff, folks? 489 plus 36. Take away 625. Negative 100. All right, from there, I think we're doing all right now. So let's divide everything through by negative 100 so we get it in standard form. This, what I'm left with is a negative, let's see, an x minus 3 squared all over a negative 25 plus a y minus 5 squared all over a 4 equals 1. All right, standard form, equation of a hyperbola. Almost. Notice that my first term is negative, second term is positive. We want my first term being positive, so I need to switch these two around because this is the negative term. So a commutative property of addition allows me to rewrite it as y minus 5 squared over 4 minus there we go. Now all is good. We are able to identify that this is a hyperbola. We notice that the y squared term is my positive term, so my transverse axis is the y-axis, which means that my 4 is my a squared. 25 is my b squared. So from there, let's go ahead and plug in what we know. So a is 2, b is 5, c is a squared, which is a 4 plus a 5, 4 plus a 25, which equals a 29. C equals root 29. Nice, easy, fun number. H and K is what's left. Since it's in standard form, y minus, so H is a 5, and my K is a 3. All right, we have all the information that we need. Let's go ahead and draw and start to draw some of the information that we have here. Something doesn't look right. Are those two reversed? I think so. All right. I think I'm feeling a bit better about that now. Draw our tick marks. I have a new center over at H is 3 over 3 and up 5. I'm going to run out of space here, guys. That's kind of ugly. All right, so this point here then is a point 3 and 5. My A is 2 units above that. So I can draw a dashed line 2 units above and 2 units above and 2 units above and 2 units below. My B is 5 units to the left and right of that point. So over at 2 and -2. And over at 8, way over here. That's going to be over in my work that I've been doing. I did not draw that in a very good spot, did I? Oh well. And now we can do is draw our box. We have a foci that's root 29 units past that, which is between 5 and 6 more units. So back up to a 2, a little bit past it. Well, our axis, our new transverse axis is right there. Our vertice. And then from there, we're able to go ahead and graph. Yeah, that one got kind of messy over there, but it's a reflection about there. All right, point of this one, we were able to go ahead and start with something that was very messy, use the completing the square method to go ahead and resolve it back down to hyperbola in standard form. And then from that standard form, it's just what we've been doing all along. Find its center spot, find the box, find the asymptotes, find the foci, and fill in the points that you can with a nice smooth curve.